Okay, today we're going to be talking about temperature. When we discuss temperature in life, we generally discuss temperature with relation to how we feel, okay? If it's outside and it's a beautiful day, we typically think of temperature as being somewhere around 75 to 80 degrees Fahrenheit. So there are different scales that describe our temperature with respect to what units we're comfortable with. In the English system of measurement, we generally think about temperature in terms of the Fahrenheit scale. In the metric system of units, we typically think about temperature in terms of the Celsius scale. There's also a third scale that we're going to use in chemistry called the Kelvin scale. But before we get into the scales, let's talk a little bit about what temperature is. Temperature is an indirect measure of energy. By definition, temperature is a measure of the average kinetic energy of a molecule. The more kinetic energy a molecule has, the faster it's moving. The faster it's moving, the more energy it transfers in a collision. You can imagine this as if you're driving down the road in your car. If a tree jumps out in front of you and you're going 5 miles an hour and you hit the tree with your car, you get a slight dent and a slight jolt to your body inside of the car. But if you're going 55 miles an hour and you have much more kinetic energy and you hit that tree, you get much more than a slight dent and a slight jolt. Same thing on the molecular level. Whenever we're looking at molecules, atoms, groups of atoms, and we're trying to measure the temperature, we're actually measuring how much kinetic energy is transferred between the molecule and the thermometer. Okay, whether it be a digital thermometer or an electronic thermometer, or maybe a bimetallic strip like you would use in your home to turn the air conditioner on and off. So temperature is an indirect measure of energy, and that energy is in motion. Now for science, or for chemistry, we're going to look at 3 scales. The Fahrenheit scale and the Celsius scale. Both are dependent on the freezing point and boiling point of water. The boiling point of water on the Fahrenheit scale is 212 degrees Fahrenheit. On the Celsius scale, it's 100 degrees Celsius. The freezing point of water on the Fahrenheit scale is 32 degrees Fahrenheit, and on the Celsius scale, it's 0 degrees Celsius. So, for a difference between boiling point and freezing point on the Fahrenheit scale, we have approximately 180 Fahrenheit degrees of difference. For a difference between boiling point and freezing point on the Celsius scale, we have a difference of 100 Celsius degrees, not 100 degrees Celsius. So, when we write down a temperature, we always put the degrees before the symbol that represents which scale we're using. When we're talking about differences in temperature, we always put the scale we're using followed by the degree sign. So, in looking at these 2 units of temperature, or 2 measures of temperature, or 2 scales of temperature, however you want to define it, in terms of how they're related to each other, there is approximately 1 degree of Celsius temperature change for every 1.8 Fahrenheit degree change. Once you realize that you're at different freezing points and different boiling points. So we've got to work on converting between Fahrenheit temperature and Celsius temperature with that in mind. So we also notice that the Celsius temperature scale starts at 0, whereas the Fahrenheit starts at 32. So if we're going to work at a conversion here, or look at some type of conversion with respect to these 2 temperature scales, we're going to have to take that into account, that 32 degree difference, and the fact that 1 Celsius degree is equal to 1.8 Fahrenheit degrees. So if we've got a situation where we want to convert to degrees Celsius, for instance, you have a friend that lives overseas and you want to tell them how hot it's been here or how cold it's been here. You want to put that in terms that they can understand in degrees Celsius. So degrees Celsius would be equal to 5 ninths times degrees Fahrenheit. But I wouldn't just say the degrees Fahrenheit, I would have to subtract 32 from it because Fahrenheit freezes, water freezes at 32 degrees above 0 in Fahrenheit. Now this, how does this relate to that? Well, I could write it this way, degrees Fahrenheit minus 32 over 1.8. Because 1.8 degrees Fahrenheit, 1.8 Fahrenheit degrees is equal to 1 Celsius degrees. But in reversing that, if I've got my temperature in degrees Celsius and I want to convert it to degrees Fahrenheit would be equal to 9/5 times degrees Celsius plus my 32, or degrees Fahrenheit would be equal to 1.8 degrees Celsius times my degrees Celsius plus 32. So I have two conversions here, two relationships. So I can convert from degrees Celsius to degrees Fahrenheit or degrees Fahrenheit to degrees Celsius. Both of these temperature scales are based on the freezing point and boiling point of water. But we know that water freezes at 0 degrees or 32 degrees and boils at 212 degrees. A lot of chemical processes occur above 212 degrees Fahrenheit, and a lot of chemical processes occur below 32 degrees Fahrenheit or 0 degrees Celsius. So we need another temperature scale, and this temperature scale is called the Kelvin scale. The Kelvin scale is based on the concept of absolute zero, okay? It was proposed by Lord Kelvin, and the definition of absolute zero is the temperature at which all molecular motion ceases. Or, if we want to look at it in terms of the laws of thermodynamics, we can look at it in terms of the third law of thermodynamics. At absolute zero, the entropy of a pure crystalline substance is equal to 0. Or in other words, we have a pure crystalline structure at 0 Kelvin. Everything is perfectly ordered for a pure substance, or all motion ceases. Now, Kelvin temperature is based on this concept. So at 0 Kelvin, there is no motion. As you increase the temperature, the amount of motion increases. Since we have this third temperature scale, we need to relate it back to our other temperature scales so that we can describe things that occur. So our Kelvin temperature is equal to our degrees Celsius plus 273.15. So if I have 10 degrees Celsius, that's 283.15 degrees Kelvin. If I have negative 10 degrees Celsius, I would take 10 away, so that'd be 263.15. So here are predominantly the three units, or three systems that we're going to use to measure temperature. Fahrenheit, Celsius, and Kelvin. Are those the only three? No. You can devise your own units of temperature based on whatever you want to. You can devise a Smith temperature scale. If your last name is Smith and you want to devise a temperature scale on Smiths, and a Smith at 0 Smith, that's equal to 12 degrees Fahrenheit, you can devise your own temperature scale, and then you can convert it back to Fahrenheit and Celsius and Kelvin. But in our class, in our work, we're only going to use these three temperature scales: Celsius, Fahrenheit, and Kelvin.